All right. Hello and welcome to our debate. My name is Jonathan, and today I will be arguing in defense of the Bactrocera olei, which has a more common name of the olive fruit fly.
And I am Kyle Haynes, and I will be arguing in the defense of the Homolodisca vertripennis, commonly known as the glassy wing sharpshooter. And we will be discussing the topic of which causes the greatest loss for olive oil producers.
To start off this debate, I'll be talking about the Bactrocera olei, better known as the olive fruit fly. This pest is one of the greatest threats to olive oil production, especially in the United States. This native to eastern Africa has made its way over to California, with the earliest detection happening in 1998, but has been devastating Europe, North Africa, and the Middle East long before that. The olive fruit fly is a very tiny insect, coming in a total 5 millimeters long as an adult, with a wingspan that is only double that. The adults have brown and yellow markings, while the larvae are white. The larvae and eggs grow inside the olives, which is where the problem stems from. The female deposits the eggs in the olive fruit, which hatch 2 to 3 days later and start eating away at the flesh of the olive fruit. As the larvae develops, it destroys the olive, ruining the possibility of it being used for consumption or olive oil. Despite the research done on mitigating this issue, there are still some concerns with the solutions. The insecticide that is used to combat the olive fruit flies need to be applied every other week and is not cost efficient for those who apply it. Attempts at biological control have been made, but to limited success. The only other effective control is mass trapping. However, this takes lots of time and sometimes requires the use of chemicals. Since these control methods are limited, olive fruit flies can run rampant through crops with the ability to destroy up to 100% of the crop. When not taken care of, the olive fruit fly changes the chemical characteristics of the olive fruit and can ruin up to 80% of the value of the crop.
I will now be talking about the Homolodisca vertipennis, commonly known as the glassy wing sharpshooter. This is a pest insect as well that is native to southeastern Europe and was introduced to the Southern California region in the late 1980s. This insect is one of the main vectors of a bacterium called fastidiosa, which is a plant pathogen that can transmit Pierce's disease, making it one of the greatest threats to olive oil production in the United States. The glassy wing sharpshooter is a rather large leafhopper insect that reaches an average length of 12 millimeters in length as an adult. They are usually dark brown or black, and their wings are clear with a red vegetation that will fade in older specimen. Their abdomen are whitish yellow, and their heads are covered in yellowish spotting. They are part of the Hemiptera order and are part of the same family as the cicada insects. Their life cycle is egg, nymph, adult. They are born. When they are born in masses of around 10 to 12 eggs and hatch in around 2 weeks into their nymph form. When they hatch and emerge as nymphs, they do not have wings and they look like their adult variation. They are only smaller. Uniform gray in coloring, they do or and have prominent eyes. They will progress through 5 development stages towards adulthood, each time molting and shedding their skins. After their final molt, they will merge with their wings, and which will take a couple of hours to fully expand and harden. The glassy wing sharpshooter has an impact on olive oil production, stems from it being one of the main vectors of this bacterium, Xylella fastidiosa. As I mentioned earlier, this bacterium has an effect on olive orchards in the southern Italy range, killing millions of olive trees. The glassy winged sharpshooter can spread its subspecies, the puka strand, which is associated with the Xylella fastidiosa. Majority of the olive orchard production in California occurs in the Tulare County, making up more than 50% of the production for the state, and that area is located in a GWSS identified infected area. The way that the Xylella fastidiosa affects its host plant is by invading the conducting water conducing system or conducting systems by restricting and blocking water and the needed nutrients for olive trees, leading to a serious consequences for the plant, including reduced production and even death of the host plant. Research has been done on the three control methods, including cultural, biological, and chemical. There are currently no cultural controls available. However, careful inspection of transportation of plants to California is done in hopes of controlling the spread in this state. Biological control efforts include the introduction of multiple species of small wasps in the genus Cosmocomidia, which has introduced a population of parasitoids there that has been a parasitism of 10 to 90% mortality rate of the glassy wing sharpshooter, depending on the time of the year and the breeding cycle. Lastly, the chemical control measures are not recommended for most established areas in California, as the natural predator insects that aid in the control of these species can be harmed. However, the state and federal governments may use chemical control agents in a new area that is being identified so they can control the spread of this impactful insect.
A counter argument that I would propose would be that since the control methods yield high positive results, the sharpshooter does not cause as great of a loss as the olive fruit fly. Debater B mentioned that at some points of the year, the mortality rate of the sharpshooter was up to 90%. This means that during those time periods, the effect they had on olive oil producers was essentially close to zero. Also, the bacterium Xylella fastidiosa is not created by the insect; they are just the main vector for it, which assumes that most, but not all, of the insects possess it. So during this period, when the population is low and only a percentage of the population may actually have the bacterium that affects the olive fruit fly, the loss of olive oil that is produced may not actually be as great as potentially other parts of the year. Therefore, the overall loss throughout the year goes down because the bacterium that can harm olive oil production is low during a part of the year. While this is only at the highest point of the year, there's still a 10% reduction in population at the lowest, which means the population is still decreasing overall. Again, with this population, only a portion of the population contains this bacterium. Overall, it's not the insect that is a threat to the olive oil industry, but rather the disease that they spread.
I would like to counter this argument by pointing out that the olive fruit fly only affects the olive itself, and not the tree that hosts the olive. With that, or with the argument presented by debater A, he states that they make the olives not consumable. Once a tree is infected, however, with the Xelia fastidiosa, it is a non-curable disease that gradually destroys the entire productivity until there is nothing there, yielding less olives with each season with the infection of the trees. Uh, Another thing to consider is that they can spread the infection to surrounding trees through the roots. So this means that the gradual yielding of olives is not an option. The tree needs to be eradicated before it causes a larger issue. Lastly, my issue infecting the entire tree and the olive fruit fly is only affecting the olive that has eggs laid in them. Mine would cause the most loss for the industry.
From the rebuttal presented by debater B, he mentions that the olive fruit fly lays an egg in the fruit and not the tree. This is true. However, the language he uses implies that there are only a couple of eggs per olive fruit fly every year. This is not the case. A single female olive fruit fly can lay as many as 500 eggs per year, with up to 5 to 6 generations every year. These eggs can also be laid in both olives on trees as well as olives that have already been harvested, threatening the production of both last year's harvest and this year's harvest. This also does not account for the times where a female may attempt to deposit an egg in an olive, yet the olive rejects the ovipositor. In this case, the cut on the fruit from the ovipositor still leaves it open to infection. With this amount of olive fruit flies, that would be equivalent to an entire tree of olives, if not more. To pose another counter argument, debated B mentioned that there was no cultural control for the sharpshooter. However, upon inspection of the I used, sources used, I found the mention of a cultural control that proved to be helpful not only preventing the infection of Xylella fastidiosa, but also providing rootstocks to new trees that would decrease the presence of the sharpshooter. With this implemented, the problem could decrease over time as more and more trees would become resistant to this disease, thereby eliminating the problem that the sharpshooter caused.
On further investigation, I noticed that olive trees can only yield about 1,000 olives at once, with the average olive fruit fly laying up to 500 eggs in a year. This does not come close to the level of destruction that the sharpshooter has. If one were to assume that the olive fruit fly only laid one egg per fruit, they would have the possibility of destroying half of a tree, whereas the sharpshooter has the destructive capability to destroy the entire tree, along with contamination of surrounding trees. Debater A also mentioned that the olive fruit fly can also infect harvested olive fruits, creating a bigger production impact. However, the tree is still operable and has the potential to continue producing olives for future harvest, whereas the sharpshooter destroys the entire tree, forcing the cultivator to remove the tree and replant. The average time it takes to plant a new olive tree and grow it to maturity for harvesting takes 3 to 12 years, depending on the variety of the tree. I'd argue that this causes way more long-term production harm, financial strain, and implementation of time restrictions.
To close out this debate, I would like to reemphasize that my argument is that the olive fruit fly, Bactrocera olei, is a greater threat to olive oil production than the glassy winged sharpshooter. As my opponent stated, a single olive fruit fly could destroy half an olive tree with just its eggs. This does not account for any additional damage it could cause outside of laying the eggs. Additionally, to prevent the spread of the olive fruit fly, there are only a few options for control, with both options requiring a high cost to the producer. Whether it be chemical control or cultural control, this cost would be close to $3,500 per producer, would be on top of any loss they would experience from the damage of the olive fruit fly. My opponent focused mainly on the population of the olive fruit fly and the means of destruction. However, I would like to reiterate the argument that research and development on control methods have gotten stronger for glassy wing sharpshooters, mainly biological and cultural control methods that had had varying success, but success nonetheless, with future improvements on the way. With improvements, both the root cause and secondary cause would be eliminated almost in entirety to the point that, possibly in the near future, the glassy wing sharpshooter may not be able to infect the disease that actually kills the olive trees. In research, the olive fruit fly has been used to find new ways to control both chemically and biologically. One point of research is finding how to effectively control the attractiveness of the olives to the female fruit fly and how altering the olives could prove to be a way to limit female fruit fly infestation. Another point of research is finding parts of the olive fruit fly's biology to determine what are the best parts to target when developing a chemical retardant. This research would be to specifically target areas of the insect that would not be able to evolve to become resistant to the insecticide being used. To conclude, both of these insects are important to study because of the negative effects they have on the olive oil industry. Finding ways to ethically and sustainably combat these push to scientists to find innovative ways to combat this issue while maintaining the environmental integrity of the ecosystems that these insects attack. It is also important to study these insects because they remind us of the importance of studying the environment and how each insect plays a role in the ecosystem, making sure that we don't harm those may be serving us. Thank you.
Within this debate, I've shown that the glassy wing sharpshooter poses a much greater threat to olive production operations, mainly due to their roles as the main vector of a devastating plant disease known as Xylia fastota. The olive fruit fly, though a very impactful insect to the olive oil production industry, only affects the olive fruit itself, whereas the glassy-winged sharpshooter infects and destroys the entire tree. The effects of this disease are not treatable and spread to surrounding trees if not managed and dealt with, and ultimately cost the cultivators more money since they are losing the harvest, pay for the new tree replacement, and lastly, wait for those trees to reach maturity for future harvest. The research I have found and discussed in my opening statement and have spoken on the fact that Zelia fastota is a non-curable disease, making the options for prevention harder to implement. I understand that debater A mentioned the possibility for cultural control measures, but the options have proven to not be successful in the prevention of spreading of this disease in a highly saturated olive oil production area. The research I have presented on, and the other infected areas such as southern Italy and Spain, in addition to the effects in the California, are undeniable proof that this threat poses the greatest threat to olive oil production in California. Furthermore, with the research laid out by Conklin and Mazel, it points that if continued research into the glassy wing sharpshooter is crucial in the agricultural industry because it is likely to aid in the development of better biocontrol methods and potential plant resistant strands. There are several other industries that are being affected by the glassy wing sharpshooter, including grapes, almonds, and other varieties of crops. But in this case, of grapes, 99% of the United States grape production comes from California. So it's continued understanding and research of this insect that is crucial to economic health in California and in more aspects than one. Lastly, I'd like to restate that I understand that olive fruit fly does contribute to the loss of olive oil production. However, it does not destroy the foundation of the production efforts for the tree itself. Once the Azalea fastosa takes hold of the olive tree, it is a devastating outcome that results in the loss of olive oil production, money and time, and cost time-consuming process that comes with the removal and replacement of these trees. For those or for these reasons outlined, the glassy-winged sharpshooter, in my opinion, should be considered the greatest threat to olive oil production in California. This insect is inflicting economic, environmental, and long-term hardship on this community and industry. The damage imposed on this industry far exceeds that of the olive fruit fly and should be not taken lightly. Thank you.